All right, we are live here at Southern Illinois University on a beautiful sunny day. We've got Bree here. It's that right there, yeah. Actually, let me grab my phone. Here it is. So, depending on the camera that you're looking at, so that's the side. So now you're looking over there. Okay. Yeah, look at the top little picture. The top left, that's as about live as we're gonna get. And this is the top picture right there. So we've got 3 camera views, but for the most part, this one's gonna be the main one that we look at here. And Bree is a transfer student from Sinclair Community College. And that's in Ohio. It's a very good school. Did you have an automatic transmissions class there?
Yes, I did.
She did. She had one. And I'm repeating her because I've got a microphone on, she doesn't. But she's interested in this transmission. We're taking a comprehensive diagnostics class where we go through just about everything. And I have a vehicle here that's had a blown transmission in it, and she is really interested in taking this transmission out and apart. So we took it out yesterday, and today we're going to take it apart so that way we can see what all it needs and figure out why this failed. This transmission did not shift into 3rd or 4th gear. So a 3/4 clutch failure is what we're assuming. Very common on these 4L60Es. Anybody that's worked on these knows that's probably the #1 thing that fails on it. And there's a bunch of things that can cause it. It had 200,000 miles on it, so we can't really, some people say, oh, maybe it just wore out. Well, clutches and components just don't wear out. Matter of fact, a transmission will live forever. There's no wear capacity on a clutch or a friction element inside here. They're already so thin to begin with that there's really nothing, no room for them to wear. So usually when these things fail, it's because they don't get adequate pressure applying the clutches. These clutches slip and they burn up, and then they're done. So I'm gonna put some gloves on because we got so greasy yesterday. It took me half hour to get all that grease off. And Bree, you're just gonna hang out and watch, right? Is that okay, she said yeah, she's just gonna watch. Sometimes just sitting back watching somebody else screw things up, you learn more because you can critique and analyze and point out all the things that they're doing wrong. So, all right. Now I did this yesterday just to make sure they break loose. These bell housing bolts, I wonder if I can switch with these. Yeah, okay. These bell housing bolts right here, they take a special Torx bit, and I brought the Torx bit over, and it is, and it says on it, this is actually the special tool, but you can get this, you can order it from, it's just a normal, I think it's a T55 or a T60 plus. What makes it different is at the end of it, they're thicker. It's not just the normal Torx. The Torx are normal ones are too thin, and they stand a chance of rounding those out. So this is thicker, and sometimes they stick in there. And what a lot of people will do is they'll take a propane torch and heat the case from the outside, and that helps. Hitting it with an impact, just zapping it, that usually helps. Try not to do it with an extension, just get that torque on there. But if you end up stripping one out, I use an air chisel and catch the edge of it. You can kind of catch that edge of it, and with the air chisel, it'll spin it out, and then you're good. And actually, you don't have to take this bell housing off. It's just a lot easier to work on when you have it off. Most people, sometimes the pump won't want to come out with the bell housing in there, but you know, when you take this off, you get a little bit more access to these parts. Later units, they changed the design of this again, and it has like this little crazy 4-pointed star. They're just trying to make you buy tools, I think. That's their main goal. The tendency for people, and I made this mistake myself, is to want to take this oil pump off because you got these bolts and, you know, but you don't want to take it off yet. The reason why is because there's a solenoid that goes through the transmission case and sticks inside this oil pump. And if you try to take it off without getting that solenoid off first, you break the solenoid. And I know I've done that more than once. And I always curse myself because I'm like, I know better than that. This is an O-ring that lives, it kind of seals off the input shaft and separates the apply oil and release oil for the torque converter. And, okay, so we're gonna go ahead and blast off this pan. See if I got the right size. I normally don't let the students use air ratchets or electronic ratchets because they tear up the lab units, and I try to make them last. But in this case, this one's actually a live job. It'll help us get this apart quicker, maybe. Now, Bree, you're not supposed to laugh at me. I know, it's hard to avoid. I apologize for not wearing safety glasses. Normally I would, but those glasses would fog up so much from me talking with these masks on. Still dealing with COVID here. Seems to be getting better everywhere, but maybe it's because we're wearing masks, or I don't know. Oh, it's the top of my head. Maybe I'll switch to that view again. The phone's gonna be a greasy mess when we're done doing. I wonder what this pan's gonna look like. I think it's gonna be nasty in there. It's not too bad. A little muddy. Actually, I thought it was gonna be way worse than that, didn't you?
Yeah.
Because the oil coming out of this thing was just chocolate, or even worse. It was chocolate like my son likes to make chocolate milk. More chocolate and less milk. But I can't blame him. I think he gets that from me. Here's the oil filter. We're gonna want to make sure to reuse that. Just joking, we won't reuse it. That would be bad practice. I'm gonna unplug all my electrical connectors. If something breaks or snaps, just look away and we'll pretend that didn't happen. Oh, like that. That was a fragile solenoid. Snap that right off of there. Add that on the list of parts that we'll need. Some people actually replace the solenoids when they take these things apart. They just put all new solenoids in them. I don't do that. Now, this solenoid right here, this is the pressure control solenoid that I'm taking off. And this pressure control solenoid, they're actually not very good, this vintage. So a lot of people, when they rebuild these, they'll switch this vintage solenoid to an earlier one, like one that came out of like a 99 or a 2000. Because for some reason, when GM went to that solenoid, it failed more frequently. This is the 3/4 downshift solenoid. Later units don't even use this solenoid. Matter of fact, later units don't have this assembly, which is a pressure switch, and they don't have this solenoid. So they figured out ways to make the transmission work without those electronics. Now I have to pull this solenoid out right now. So they purposefully put these clips in, this clip right here especially. They put this one in so I can get the clip out. I grabbed the pick with the dull end. Let me get a little screwdriver here. So I can actually get this clip out. There we go. See, that's a little solenoid clip. Now I can pull this solenoid out. This is the torque converter clutch PWM apply solenoid. And we might keep an eye on to see if people have questions or anything like that, you know? Do you think anybody asked a question? The chat there says on the top, I don't see any comments, so. You do? Where?
Wait, would it pop up?
I think on the YouTube one it says SIU say something, live chat. I don't know, maybe we'll walk over there and look at it a little later. I've got everything divided into a single monitor and it's so small, can't really see much. Okie dokie, so I'm gonna go ahead and lay this, let's take this solenoid out here. This is the torque, this is that solenoid I was talking about that if we didn't take it out, we'd break when trying to remove the pump. So you definitely want to take this solenoid out now. This is the torque converter clutch solenoid. We have two torque converter clutch solenoids. This one right here determines whether the clutch is applied or released. And then the one I pulled out earlier and laid down somewhere already, okay. And then this one right here that I took off first, this determines how hard the torque converter clutch is going to be applied when they apply it. So it's kind of a dual action. The real early, like the 1993 and 1994 4L60s did not have this solenoid. So it's just on and off. Okay, now I get to pull my valve body off. And I like to, when I loosen things, start from the outside and spiral in. And then when you tighten things, you start on the inside and spiral out. But we're loosening now, so. 3 special bolts that are a little bit different than the others are this one right here, here, and here. These actually have 8mm heads. Remember I told you I was going to get all the tools and I wasn't going to forget any? I forgot to bring an 8mm over here.
Do you want me to grab it?
Yeah, could you? Or a 5/16. She's helpful. Hurry up, our fans are waiting. Maybe you could borrow one from Connor or something. I need an 8mm or a 5/16. I forgot to bring one over. But either would work. They're the same size. 3/8 drive would be perfect. All right, so making some of these things here. I'm going to take this as a, thank you, sir. This is our little detent assembly. And this basically gives you that notchy feeling of when you're in a gear. Click, click, click. Thanks, Bree.
No problem.
She tried looking for through my stuff.
The organization top notch.
She's harassing me for my disorganized toolbox. The reason why these are different, and you should always note the position, is because they're about 1/4 of an inch longer. The ones with the 8mm heads. And a lot of people have a tendency of putting that one right there, probably because this harness on some models, the early ones, they had a little spot for them. But the problem is with that is that the extra 1/4 inch will go through the case and it'll actually hit a part of the gear set. And that's bad news. So you don't want to do that. Okay, this is going to let us pull the valve body off. There'll probably be some check balls that are laying underneath here that might roll out on us. I've got all these out, so kind of something to be aware of, that the check balls will just going to be laying there. And since the gasket's flopping around, it might have rolled. But there's the underside of the valve body. In this video, we're going to go through and trace every single track in this valve body and explain where all the pressure goes. Just joking, we won't do that. That would take a long time. You don't got time for that. So,
I do.
You do?
Yeah.
Okay. Oh, look at that. This is a real common problem with these transmissions, is the check balls beat the snot out of this the spacer plate, and they get stuck sometimes. And the plates are actually cheap. You can buy these plates for about $15 to $20. And the new ones, which are cool, already have the gasket embedded in them. So you don't have to use separate gaskets. So right there, that check ball's stuck inside the transmission spacer plate there. It's about ready to push through to the other side. About that, huh? Kind of slimy. Okay, we've got, this is an accumulator spring. This is for the 3/4 shift. So when you shift from 3rd to 4th, this accumulator piston strokes, compresses this spring, and squeezes fluid pressure that's on this side out. This helps cushion your shift. That's the blue spring. Okay. And I'm going to go ahead and finish taking just a few things out. Then we'll kind of spin it around, let some of this oil drip out. We'll take the oil pump off. That's loud. If you rebuild transmissions, you probably have tinnitus. So loud noises like that are no fun. Okay, I'm gonna have to get a ratchet on that. Did I bring a ratchet over here? I just assumed I was gonna blast everything apart, didn't I? She's helpful. Appreciate that. Oh, thanks, Steve. Steve is another student. He's over there, and he's taking apart a transmission or putting it together. Oh, goodness, that's tight. Real tight. So I'm teaching 490, and I was just commenting that just this last 10 minutes ago, or whatever, every student that was here was working on transmissions, and it's not really a transmission class, but it just shows you how cool transmissions are, right? Slippery. All right, well, at this point, this little accumulator that's in here, I might not be able to get it out. Yeah, I can get it out with this thing. There's the pin that the accumulator rides on, right here. Maybe I'll switch over to this view there. And the accumulator is still in there. This is something that actually I got an upgraded accumulator from my good buddy. His name is Robert Bateman he works for a Seal aftermarket company. Have you ever heard of it? Where have you been? Steve, you ever heard of Seal aftermarket company?
It sounds familiar.
Yeah, see?
He didn't say yes, but okay.
Whenever I say something, Steve just say, yeah, that's a great company. They make kits and products to kind of help improve, transmissions. And one of the things they've done is they redesigned this accumulator piston, and it's like a perfect seal. So we'll go ahead and we'll put that in there when we go back together with this. But the main goal of this, and we're going to drop a check ball when we do this. There's one right there. Maybe I can pull it out. But the main purpose of this little stream is to take it apart, and then once it's apart, we'll do another stream, maybe in a day or two, of after we've cleaned all the parts up, and point out everything that we found. And then we'll do our final stream when we get all the parts and we go back together with it. We work kind of slow here. We're not like production shop, so we can take our time to do things. This is the oil pump. The torque converter, which is driven by the engine, of course everything would be sitting horizontal like this. The torque converter, which is driven by the engine, it fits right here in front. And there's two little slots cut in the hub of the torque converter. The engine is driving the torque converter. As soon as you start the engine, the torque converter housing's spinning, and those slots go in there and grab part of this oil pump. And then that way the pump spins, it sucks fluid in, pressurizes what it needs to do. And then this valve body over here, its job is to deliver that pressure where it needs to go, to different clutches, fill the torque converter up with fluid, lubrication, all that kind of stuff. So this pump right here obviously is really important, and we are going to take it off, and we will eventually take it apart to make sure it's not torn up inside. Okay, everything's on a little tighter than I expected it to be. Either that or my little DeWalt is it's not really that tight. I like to stagger these when I loosen them, so that way I'm kind of releasing the tension evenly. I don't think it'd hurt anything if you didn't do a star pattern. But it's these little things that I do that I feel go the extra mile.
That's what my teacher taught me to. So.
Really? I'm your teacher.
Well, my previous.
Your better teacher?
Yeah.
Oh, you were so quick to agree. Okay, now in the service manuals, they actually show a special tool to take this pump off, but you don't need one. I'm gonna grab this pry bar. Oh, can you hand me that soft-faced hammer right there? You can go into this opening in the case right here. I'll spin this around so people can see that opening. right there. I got my pry bar stuck in there. And I'm going to pry down on it. And that's going to lift this pump out of the case. And it might not want to come straight out. So because prying on it's going to kind of cock it sideways a little bit. So if I tap the input shaft a little bit, see how it's coming? Ta-da! The special tool pinches onto this and pushes off of that. And it works on some transmissions, and some transmissions it doesn't work because, like this one here, it doesn't have it has a real small recess. But the ones that they work better on are the ones that are like machined down right into this section. And that will kind of give it a place to grab onto. But this one's smooth almost all the way up, so it wouldn't have worked very well on this one either. So the gears, the pump rotor, and the pump slide, and all the pump parts are in here. We'll take it apart in a bit. The early units had an O-ring around that seal it off. And these later units use this like wedge seal. And I call this a later unit. This is a 2006, so it's not really that new. But I want to say they stopped using this transmission pretty much for good in around 2012. But the first version of this, not the electronic version, came out in 1982. So 30 years they had this, pretty much this transmission. The first electronic version of this transmission was 93. And then they made it like the removable bell housing in the late 90s. And then they added things like a speed sensor, and they upped the strength of it by putting more planets on the planetary carriers and so forth. So they continued to improve it, but there's similarities that go all the way back to 1982 on this transmission. So it's kind of wild. This on the side here, this is a Servo Assembly. This applies a band that's in there. So when we shift from first to second and from third to fourth, a band applies. And there's a hydraulic piston in there that comes over and squeezes that band, and it grabs onto this reverse clutch housing, which is splined to a sun shell, which is splined to a sun. And we'll see that when I take it apart. But before I pull this out, I need to get that servo assembly out. And I like to, before I take this thing completely apart, I'll push in on this and see how far it goes. See how far in that goes? Probably about 1/8 of an inch. If it goes in really far, that band is worn out. That seems kind of excessive, but it's probably about the upper limit of what I would think would still be okay. And then there's a little round circlip in here that'll come out. And here's a little trick for you guys taking these things apart. When you go to pull this servo out, you can see that little blue O-ring is right in there. A lot of people struggle to get that out, but if you take a pick, get underneath that O-ring, and of course I picked the dullest pick in the world, but that's probably good. So, not to say that we would reuse this O-ring, but for some reason I like to hold on to them in case the new one fails. My glove made a fart sound. Did you hear that?
Yeah, I heard it.
I swear to God, that was my glove.
Yeah, right. You blamed me for them last time.
Well, because you did fart. See how that came off? Because what happens is this falls into the snappering groove, and then it fights you. You know, this little ring that I pulled off, when this comes out, that O-ring falls into that groove. Mine not off the screen, right? Okay. And then it fights you, but if you pull on it, if you pull on this O-ring, it's kind of squeezes it down, right? Becomes thinner when you start stretching it, and then allows it to come out. Isn't that a cool trick?
Yep.
You heard it here first. I didn't invent that trick. This is the servo assembly. Servos are pretty cool. Of course, I'm a transmission guy, so everything's pretty cool to me that involves a transmission. So this is the piston that applies fourth. There's the cover. So when this thing shifts from first, I'm going to let the spring just go over. When this shifts from first to second, pressure gets in between these two spots, and it moves the servo piston over, and then applies the band. Then when it shifts in the third, and remember we have a 3/4 clutch failure. When it shifts in the third pressure gets on this side, and it releases the band. And then when we shift into fourth, we still have our second pressure and our third pressure there. We never Like once you shift in the second, you never release it when you shift in the third. It's there the whole time. And when you shift in the third, you have second and third. And when you shift in the fourth, you have second, third, and then fourth comes on the end. Actually finds its way through this hole right there in the shaft, comes through the hole out to the end, and applies this piston and independently applies the servo. So it's like second, third, fourth. Something to think about how that's designed. It's pretty cool. And now I can go ahead and pull this input drum out. Ta-da! And this is the reverse clutch housing. So the reverse clutch is inside here. The band grabs onto this housing. A lot of technicians, you got to measure this for flatness. And it's pretty simple to do. You just take a ruler with a straight edge across there and just see if there's any light showing underneath it. If it's pretty flat, there's nothing wrong with reusing it. If it's been slipping, it's probably bowed in. A lot of people, including myself, just machine the surface flat. But a lot of people believe that that's bad practice. They think these drums aren't thick enough to do that. So I guess it depends on how you're using it. If you're going to put this back in a Corvette or a Camaro, I don't know. I don't know why I talk like that. But if you do, you'll want to probably get a new drum. This is that band. And actually that band doesn't look bad at all. So, do you think you replace this on every transmission overhaul?
Depends on how it looks.
Depends on how it looks. That's a good approach. Now, if you live in California, you have to replace it. It's the law. Yeah, anything that's considered a wear item needs to get replaced. It's a law. A lot of builders do not replace things that look good, especially steel plates, band, and because if you think about it, that still looks like it does from new, and it measures out, and there's no real. Sometimes you can still see the inking on it, and you saw the drum really didn't look bad; it didn't look like it was slipping. So if that stuff, if it lasted 200,000 miles and has no signs of wear, some would argue that this is a known good part, And whenever you get something new that's never been installed in anything, have you ever heard what new stands for?
Nope.
Never, ever worked. That's what new stands for. So when you have a new child in your life,
Yeah.
that child has never, ever worked. That's what new. I mean, it's
That's really
it's
what it
a,
stands for?
yeah, it's the Greek term newithin.
Okay.
New. I'm making stuff up.
I'm like, okay,
I'm messing with you,
that
man.
makes sense.
I like messing with people.
If you don't know what you're talking about, well, you're always going to be right. Well, if I don't know what you're talking about,
Yeah, that's the beauty of it, man. I mean, I say stuff all the time, and
I just shake my head.
people are like, wow, he's smart. This right here, there is a special snap ring pliers to get this out. And you know where it's at?
Not here.
I don't know where it's at either. I'm asking, you know where it's at?
Oh, I know. Nope.
So I'm hoping I can get this out. It's usually I can get this with this one. This is kind of a modified one. I created a notch, but it's slipping.
Is the special one longer?
No, it's actually real small.
Oh.
It has a sharp 90-degree right on the ends here.
I don't know if I used that to take off, I don't know, I'll probably use them.
I'm gonna try this one, and I got my hand on the shaft down here because once it's out, it'll fall. But since the snap ring pliers are fighting me, I'm just gonna let it fall if I can get this snap ring out, because otherwise, hey, it didn't fall. I don't know why. Must be stuck in there. Okay. I'm gonna give it a couple taps with the back of my, there we go. See that? That's your output shaft. Don't mind that. We don't need that part. The output shaft, these are parts where our gear set's gonna spline to. This is where the transfer case splines into. That's why they call it the output shaft. Then these are our planetary gears. This is the GM calls this this is that snap ring I was fighting there a little bit. GM calls this the input planetary gear set because it's on the front half of the gear set. And they call everything on the back half of this gear set reaction. So everything on the reaction is on the rear, everything on the front is called input. I don't really like the names because like this is splined to the output shaft, but yet you call this an input carrier.
Yeah, that's pretty confusing.
That's why I like to explain that everything on the front half is input, everything on the back half is reaction, even if it's not what they do in real life. There's a Torrington Bearing here. We pay close attention to these bushings. They keep the gear set kind of centered, and there's going to be more gears coming out here in a second. So this is a reaction sun shell. This is a notorious part in 4L60Es. They snap a lot of time right there at this joint. So, and then sometimes you'll take these things apart and you'll look right there where this spline section kind of curves over to the bottom of the shell. It's split. And sometimes the splines rip out right here. And if you also look, these little fingers, like these actually are flared out a little bit. Sometimes they'll flare out, and that's not good because they can actually hit the inside of the case. I've seen pictures of these transmissions of 4L60Es with the case cut open because this thing spins up so fast and the actual teeth, the little lugs right here, end up machining a groove and causing the transmission to fail. And what that does is that goes in here and catches onto this gear set, the reaction sun shell. The sun shell connects to the reaction sun gear. This is starting to make some connections here. And we'll look at all these parts when they're clean, but the reverse clutch housing, when that reverse clutch applies, it drives the sun gear. When the band is applied, it holds that sun gear. See how they interconnect all these things to work? Mm-hmm. Isn't that cool?
Awesome.
Yeah, that's awesome. I love transmissions. Okay, so there's a snap ring down in here that holds this reaction support assembly. I'm going to pry this open. And the opening lives right in this spot. And there's a device down here, it looks like a bent spring. I know you can't see it, but there's like, it looks like a lot of students would go, man, I think something got caught up in here. There's a snap ring that's all mangled, but that's actually supposed to be there. It's called a case saver or anti-rattle clip. Hey, it's our Eduardo, he's watching us.
Oh, that's funny.
What are some common upgrades when upgrading the 4L60E? Well, I tell you what, there's a lot of, you'll get a lot of opinions out there. If I had a performance vehicle, one of the things I would probably do, I'd do a lot of research, but Transgo is a company that makes performance shift kits and they make shift improver kits. They're not that expensive, and what they've done is they study these transmissions and how they fail. You know, not from a fresh, brand new transmission standpoint, but like something that's got 150 or 200,000 miles on it, and they look to see how they wore out and how they failed, and they make a kit that allows you to kind of correct for all these little things. Because it wouldn't make sense when you overhaul a transmission to put a new valve body in every one and put new gears in every one and a new drum. So they look to see what can we do to basically bring that valve body that controls all the pressures to all these clutches, what can we do to bring it to a like new state and something that'll last another 200,000 miles. So those types of kits are very good. Superior Transmission makes a kit like that, Transgo. And there's a company called Sonex. Sonex makes a lot of improvements for these transmissions. And what they do is instead of modifying the existing valve body by like drilling holes or putting different valves and so forth in, they'll actually have you, and we'll do this, not this video, but the next one, they'll go through and measure all these different valve body passageways and determine what parts are worn out, because they have specs for it. Like this section right here, if you check this reverse abuse valve, for example, right here, and this low abuse valve, actually the reverse abuse is that right there. If you check it and it leaks, if the vacuum that you pull, and you gotta have it all clean, if the vacuum you pull on this is too low, that means the clearance between the valve and the bore is too great. So they have a fix for that. And what happens if the clearances are too great, clutches, the pressures end up leaking this pressure that's supposed to find its way to a clutch ends up leaking out here and never finds its way to the clutch and it burns up. So you definitely have to address, so the upgrades, you definitely have to address the worn out areas, and a lot of people do that by a shift kit. Performance-wise, there's a lot of upgrades. You can get different bands. Some of the bands are wider and have a little more contact. That shell that breaks, there's a ton of upgrades there. Sonex makes a great shell for that. Sonex makes a great shell. So when you shift into second, your shell doesn't snap. That's pretty good, isn't it? A lot of S's in there. Continuing on, there's a guy, I think the website is 4L75, and maybe I'll comment on it later. His name is Mason Smith, and he makes one of those input drums. He takes these 4L60 input drums, and he machines a cap that goes on the end, and that has like these lock screws in it. It keeps that 3/4 clutch assembly in there. It stiffens that whole area up and keeps it from blowing up at high RPM. So that's a really good upgrade. And you can, from companies like Sonex, also go through and buy like upgraded shells. Some of the companies will have upgraded shafts. Honestly, I haven't built that many performance ones, so, but there's a lot of stuff. But I would address this input drum, the shell, and the band, and do a kit. And yeah, we might look at some of that stuff a little later. This is all going into an Envoy, so I don't know. Might have to crank up the horsepower on the Envoy, and we'll have to beef up the old transmission. What do you think?
I don't think so.
No? Put a Whipple supercharger on it or something? Do they make a...
New driver's son?
Yeah. No, that'd be a bad idea.
Yeah.
Okay, so I put this transmission horizontal again. It was like that. And what I'm going to do is I'm going to use the output shaft to help get this low support assembly out. So I go horizontal with it, put the shaft in there. Because there's usually, it's tight. Sometimes it doesn't want to come out because of that anti-rattle clip. So by doing this, if it doesn't come out, I'm going to have to do some trickery. There we go. I was just about ready to give up too. And the reason why, think that'll stay? Or is that going to fall right under my phone? Probably.
With your luck.
With my luck? Yeah, no, I got bad luck sometimes. So far, everything's been working all right. See, it's sitting right there in the camera view too. The reason why this was difficult to get out is my anti-rattle clip, which is right here. And I don't remember exactly where it was, but let's just say it was there. It's keeping, I don't think it was there, but.
It was there for this purpose.
For this purpose, it was here, yeah. This keeps it tensioned. It keeps this whole housing clocked in a counterclockwise direction. And the reason why is because these lugs right here on this housing, they fit into the transmission case right here. There's splines for that in the transmission case. And this little rattle clip that everyone thinks is a mangled up snap ring, this little rattle clip keeps it in tension. It keeps the lugs in contact with the aluminum. If this wasn't there, there'd be a little bit of slop, right? Obviously, because you gotta be able to get it in there. So every time this shifted, it would downshifted to first. It'd go clunk, 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 clunk. And what do you think that'd do to the aluminum lugs? Yeah, you'd end up tearing them up, and then you'd rip them out. So if this was always in contact, though, every time you downshifted, there would be no slapping of those lugs. So you definitely would never want to forget to put this little guy in there. That would be, the transmission case will be very angry with you and probably break. Okay, and this is a one-way clutch too, by the way. So built into this piece is this part right here, which is what grabs onto this, these lugs on this reaction carrier. And And it allows that reaction carrier to always spin in the clockwise direction. It's a mechanical clutch. You see I'm going clockwise with that. And if it ever wants to go counterclockwise, can't. Locked. So if I lift this out, you can see those are little rollers in there. And then you're like, well, how does that keep it from, they're just rollers. It looks like it would just spin all the time. Well, I'll show you. That's a good question, Bree. Very insightful of you. Is that the right word? I'm feeling like I'm smarter than I actually am.
It's okay, I'll let you have your moment.
Okay, thank you. So, let me have my moment. So if I slide this out, you'll see the outer race has these ramps. And so these little rollers actually will roll up into those ramp, or however you want to look at it, they'll get wedged. When it tries to go, when the inner race tries to go counterclockwise, it gets wedged, but it'll fall into the larger openings when it goes clockwise, and then I'll let it freewheel. How about that? It is. That's a roller clutch, and it's a one-way clutch or mechanical clutch. So it doesn't need hydraulics. It doesn't need anything really to happen. It's always there until it breaks, and then it's not there. But you need it. That is used when you take off in first gear. That is what holds this reaction carrier from spinning. Then when you shift into second and go to third and to fourth, that freewheels. So it really only holds just for first gear. When I pulled this shaft out with this gear on there, I also pulled out this clutch assembly. This is a low reverse clutch assembly, and it looks good. The low reverse clutch assembly is used when you're in manual low and when you go into reverse, because that carrier is going to want to spin in the reverse. It's going to want to spin in that in the clockwise direction. And that one-way roller clutch can't hold it in the clockwise direction because it wants to do that in reverse. So we need to have a clutch to apply it and lock it and keep it from spinning. We can't rely on the mechanical clutch. So, and then they also put it in low, like if you put a manual drive low, so that way when you're accelerating, not only does this clutch hold it, but the mechanical clutch does, and when you take your foot off the throttle, instead of that roller clutch freewheeling, this clutch is going to prevent it from freewheeling, and you'll have engine braking. You got all this? You writing it all down?
Well, since I've already previously taken a class, it's just a refresher.
Oh, that's good. Yeah, so it's making sense. This bottom plate was a wave plate. A lot of people might look at this and think that the plate is no good, but it's supposed to be wavy. It's like a cushion plate. It's a cushion for your tushin. That's bad. Shouldn't even talk. This is the reaction carrier, and this is the reaction internal gear. So the reaction internal gear is connected to the output shaft. So these are the parts that are connected to the output shaft, my input carrier, and my reaction internal. And I'll lay that over there. And then these two parts, the input internal and reaction carrier, are splined together. I thought I was on overhead view there. So the input internal reaction carrier are lugged and splined together. And see these little spots right here? They look like splines. That's where clutch discs can grab onto. So the 3/4 clutch, which is the one in question here, right? Mm-hmm. It grabs onto this to drive this part in third and fourth. That's why this is kind of discolored. Looks like it got hot. Probably because the clutch burnt up, splattered its burntings all over it. And then this right here is where the low reverse clutch has the ability of grabbing onto it and driving it. Not driving it, but holding it. Holds it to the case. Low reverse holds it to the case. 3/4 clutch drives it. That's that. All right. So for the most part, this case is gutted out. The only thing I have left in here is way down there, I've got my low reverse piston. And I will take that out, but I'm not going to do it on camera just because it's not that big of a deal. It just is going to take time, and I don't think I need to mess with it. I have this special tool right here. It comes in from underneath. When you thread it down, it compresses the little piston return spring, and you can get the clip off. It's way in there. It usually fights me, and I end up cussing, and I don't want to do that live on camera. Like last time, remember that one? Jeez. That was embarrassing. But got a letter from the chancellor on that one, but no, I didn't. I'm just joking. Everyone's going to be going and looking at that video. That's good. Hey, that's good because people look for that. Yeah, bring them views up. Okay, so yeah, let's take a look. I'm going to transition. We're going to shift gears a little bit. Get it?
No pun intended.
No pun intended. And we'll look at this input drum assembly. Come on, Bree. Golly, got a mess over here. Okay. Uh-huh. So I'm going to slide this. There's a hole in the bench right here. That's just for this purpose, so we can lay this in here and take this apart. And I'll drag my overhead camera. Hopefully not knock the whole kit and caboodle down and process. This should be pretty close. Maybe zoom in. I like talking out loud of what I'm doing, like that really matters. Okay, so can you hit top? She's like, no, that phone is oily mess. I don't want to do that. Okay. This is the input drum, and it's inside the first clutch that we pull out of this is the 3/4 clutch, and you're going to see it is nasty. Yeah, Eduardo, he helped pull the transmission out. What a nice guy.
He did it.
Is there anybody else? I don't see any. That was on YouTube. Oh. There's 10 people watching on Facebook though. Yeah, this it got hot. You can see it's all burnt. And this one doesn't have any friction material left on it anymore. A little bit on that side. But here's the thing. When these things wear out to a point, the piston can come up, and these little piston return springs, or they're called they're called load release springs. And they're there to keep the bottom plate and the top plate separated. That once these clutches wear off to the point, this bottom piston will come up and compress it, and you'll basically, the top and the bottom piston end up hitting this metal clip, and the piston can't go any further. So even though some of these still have clutch material left on it, the piston couldn't physically apply these anymore. But it doesn't matter because whatever caused this clutch to burn, whatever caused this, all right, yeah. A transmission can leak so much pressure, only a little bit of pressure, and still be okay. Once it gets to the point where it continues to leak, and now it's getting to a point where it's leaking more than it can handle, basically, that's when you start getting slippage. So for the most part, this transmission was able to adapt and be able to handle leakage up to a certain point. And once it got to that point, this clutch is going to slip, and then it burnt up. And once that happens, they don't have a chance to live. There's no wear capacity. If I grab a good looking clutch here, like maybe this one here, this low reverse, and I'll go back to top. The friction material that's on these things are, I'm going to guess, about 20 thousandths of an inch thick on each side of the steel plate that they're bonded to. That's not much wear capacity. It can't handle a slipping too much. It's not like a clutch on a manual transmission or a brake or something like that, where you can actually, it's designed to wear. These aren't designed to wear. They're soaked in fluid, and all that torque is supposed to be handled through this fluid, so they don't wear out at all. You'll see, like I said before, you'll see clutches on transmissions that have many miles on them, and you can still see the inking on the clutches.
Now, you said that the clearance was off on this, like if it was worn down, and pressure could escape through this valve cover, or...
The valve body?
Yeah, valve body, which would cause the clutches to slip.
Exactly. So what we'll end up doing, and I'll show this on the next live stream, once we have everything cleaned up, we need to find the root cause for this clutch slippage. And that's where, when we get to that, what we'll do is we'll look at the path that fluid travels. So pressure is important, obviously, like overall pressure. Fluid finding its way into the 3/4 clutch piston, so if the seals are damaged, which they probably aren't, but if the seals were damaged in here, that's possible. A very common area that fails is this shaft where it fits into the drum, gets loose. And you usually can't feel it, but when you air check it, you'll see bubbles coming out there. And the technicians, the rebuilders, what they'll do is they'll take this assembly just as it's sitting right now, and they'll put it in the pressure washer, the hot tank, and get it up to 160 degrees, and then air check it. And they'll put a little trans fluid or solvent on the top, and if they see bubbles, they know that it's leaking there. Because the fluid comes in, the 3/4 fluid pressure comes in, and pretty much just goes right inside this drum and applies the 3/4 piston, which is the bottom piston. And then these fingers go all the way down and apply that clutch pack. So this area, right behind this area, is the 3/4 piston. And so if you have any bubbles or leakage, another area is that little check ball right there. If for some reason that's leaking, that can cause it. Our Teflon seals, which rarely fail. These Teflon seals could cause it. Then when you get into the transmission case, there's a check ball inside here that basically seals off the third pressure that releases the servo. If it's leaking over here, we're losing third pressure, and that means we're losing third pressure there. And also, there's passageways in the valve body that they could sneak out. So there's a lot of little areas, and I don't remember which one, but I'll show it on the next live stream. The orifices that feed this 3/4 clutch, they're not that big. I mean, I don't know, probably, I'm gonna guess like 50 or 60, 70,000, something like that. So when you start thinking of all these little places that it could leak, if it ever leaked more than that orifice size, we'll lose all the pressure. So that's the reason why it's very important to have the whole, it's not just replace. If I just went through and replaced the clutches on this transmission wouldn't last a month. It would leak out. Even if I put a new piston in it and all that kind of stuff and just assume that that's all I had to do, it wouldn't last a month because somewhere the fluid pressure is leaking out, which is going to cause that clutch to fail. And it's just important to address all those areas. This is a Sprag assembly. It's called the input Sprag. So when we put this transmission in gear, the forward clutch grabs onto these splines and drives that sun gear. This is where all the torque from your engine's coming from. All that's going right into that sun gear and drive it first, second, and third. And then when you shift into fourth, they can keep the forward clutch on, and when the 3/4 clutch is applied and the band is applied for fourth, the sun gear wants to spin faster than the forward clutch, and it's allowed to do that because of the one-way clutch that's in here. It's called a Sprag. So it drives it first, second, third, and then freewheels in fourth. It will still be moving, the outer shell will still be moving in fourth, but the sun gear and the inner race will be going faster. And it's allowed to. So that way they don't have to time the release of, when they shift into fourth, they don't have to go through and...
I can do it for you.
Okay. That's, yeah, just, you can see the muddy spots there. Those are the, I switch between. Just don't, whatever you do, don't hit that one button or it'll all come crashing down. I'm joking. It won't do that. It just switches between the camera views. But I'm taking the snap ring off on it, and the Sprag is, I think it's fine. Just by feeling it, it seemed like pretty good. But you always want to inspect the inside surface of this. Make sure there's no, like, I call them rail. You want to hit the top view? See, you had one job.
Yeah, I saw.
So you want to inspect the surface that Sprag rides on. Of course, these aren't clean. We'll look at that, all that stuff when it's clean. Most builders will replace the Sprags regardless, just because they see a lot of wear, or they see a lot of, their life is rough. Let's just say that. They have a rough life. And this one's got what, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. It must be 29. There's 29 elements. I think I got an extra one. But the Borg-Warner one is what a lot of people put in there. Look at that. These are the forward clutches. Do you think those had any problems?
No.
No, they look pretty good. So this is an example of where a lot of people might just go in and not replace those.
Why is this pattern like that?
Oil, cooling, and so that is a good question though. That the pattern on that, it does affect the friction characteristics of it a little bit. but it's a way for oil to be basically transfer through these clutches while they're slipping and applying to release heat. But some of them have the grooves going in one direction and they're directional. You have to make sure they're going the right way because they allow fluid to either centrifugally fling out or pull in.
Yeah.
Ford has some that are like that. That's one of those that you have to be careful when you go together, you know which way they're supposed to go. And then these last set of clutches, these are the, whoa, it's a bad thing about wearing gloves. Everything's super slippery. But this is the Overrun clutch. There's only 2 of them. And what it does is when you put it in manual third, and you're going third gear, manual third, it applies the clutch around the Sprag assembly and keeps the Sprag from freewheeling, so it never freewheels. Or when you're in manual low, it keeps the Sprag from freewheeling. So that way you have engine braking. You take your foot off the throttle, sure. You take the foot off the throttle and it allows you to slow down. Thanks, Bree. Good job. Now this right here is the input drum. And we need to get the snap ring off so we can get the pistons out. And I might be able to do that. I usually use a foot press for that, but we might do that. Let's do that off camera. We'll have it all cleaned up and ready to inspect the next time we live stream, which might be Thursday probably.
Why not tomorrow?
Well, come on now, you know. I got things to do. Not just this, but because that way we can clean everything up, lay it out, and then when we go live, we can show everything. Look we can do the side view now. We got that side view we haven't used. It's the one in the middle.
Oh, wait.
See, look at that. Yeah, this is a professional setup we got going here. This is that oil pump. And check this out. This is something, you could tell this was they were getting ready for something. This is a 2006 model year. And as you might know, or you don't know probably, but in 2007, they started putting an input shaft speed sensor and top view. So they had the pumps ready to do that, and they have this plug right there. So normally, if you left that out, that wouldn't be good. But a speed sensor goes in there on the later units, and on the input shaft, which would be on the input drum, they'd have a tone wheel kind of right in this little area right here. Matter of fact, I wouldn't be surprised. If you see how that's machined? Yeah. It's got 2 recesses. I think they would have machined that tone wheel right there. So they were ready for it. Manufacturing was ready for it, but software engineers probably weren't. Okay, so this is the oil pump. And it's a 13 vane, 2, 4, 6, 8, 10, 12, 13. The torque converter, as I mentioned before, it has little matching lugs that grab onto these little tabs on the rotor. So when it rotates, it's going to create suction over here, pull fluid in, squeeze it out over there. And then when it gets enough pressure, this is a variable output pump. When it gets enough pressure, it's going to reduce the output. And the pressure regulator valve is going to feed oil into this passage right here, and it's going to end up pivoting the outside of that pump like that. Okay. I don't know if you can see that well, of course. I'm going to pull this spring out. Safety glass opportunity right here in a moment. I'm all right. So, yeah, that'll be a lot easier to show. So once they put pressure into this section right here, it brings the pump slide around like that, and you can see how it equalized the space around it. Now it can't suck fluid in as well, and it can't squeeze it out. Maximum outputs like this, where as this is rotating, the area expands, that creates a suction, and then we squeeze it. And minimum output, it's equal all the way around, so when this thing's spinning, there's no desire to suck fluid in. So that's how this transmission regulates pressure. It controls the output of the pump. And I probably wrongly call it a variable displacement pump because it's still displacing the same amount. It's really a variable output pump. I got corrected by that from one of my students.
I was going to say someone's going to correct
I failed his ass. No, no, I was appreciative because he went through a hydraulics program, and it's like an ag program, and they deal heavily in hydraulics. So when he was, after I covered a lecture on this, he was like, Mr. Boyle, just, you know, everything's going great, understand everything really well. Just wanted to point out, I'm pretty sure that pump is a variable output, not a variable displacement. I was like, what? You come up here and you tell me I'm wrong to my face? No, I didn't say that. He was huge. He's a big dude. He was like, he was in the military.
Yeah.
He went to Iraq like 3 times. He had tattoos of guns on his arms. And those are all the guns that he was certified like marksman trained in. Yeah. So needless to say, I was like, oh,
You're right.
thank you. Okay, good. But I remember that, and I try to remember when I talk about it, even though I forget often. So when we take this pump out apart, we really are going to inspect this for the sometimes people put upgraded pump kits in there. Transgo makes like a Transgo no yo-yo spring or pump assembly kit, which comes with better rings. That was my glove again. My glove made a little fart sound. How come I can't make it do it on command?
Yeah.
Darn it. So they come with upgraded parts for this, because at high RPM, what happens if you've got erratic pressure from the pressure regulator valve leakage or something, is this thing starts going crazy and oscillating, and that can cause pump breakage, and that would be bad. So anyway, this also has a Teflon seal in there, not seal, but a bushing. So they coat that in Teflon, it makes it more durable. Okay, so what do you think? Is there any questions you got on this here stuff so far? Really, we just tore it apart. So the next step is to clean it and inspect it.
I don't have any questions.
Good. That means I did my job. Or you just want this to be over with. So it's
No.
no.
It was quality learning.
Okay. All right. So if you guys have any questions about anything, like I said, Thursday we might go through and do the inspection stream. And then we'll figure out what parts to order. We'll get some parts coming, and then sometime next week, maybe Tuesday or something, we'll start putting it back together. And but if you have any questions between now and then, feel free to ask, and I will get to them and answer them. I'll have Bree answer them for us, you know.
Yeah.
And but yeah, other than that, I'm going to go ahead and cut the stream. And thanks for watching.